Okay, the second section in Chapter 8 has to do with some other properties that you can have with proportions. Okay, so the first one we're going to look at is you can interchange the means. Okay, so the means, if you remember, are the middle ones, because if I read this, it's A over B equals C over D. The middle letters I said were B and C. Those are the means. So I can switch those, okay? So if this is true, then this is also true. Okay, and I can check this with our cross product property, or cross multiplying. If I cross multiply the original equation here, I would get AD equals BC. If I cross multiply our new equation, I still get AD equals CB, which is the same as BC. I can add the denominator to the top of both. Now, it's the respective denominator. I can't add the opposite denominator to the top of both. Now, this is not the same as multiplying the top and bottom by something to get a common denominator. This is straight adding the denominator to the top. So I can take A and add B to it. And if I do that, I have to add the same thing on the other side. So I have to add the denominator from the other side to its top. We can check this also with cross multiplying. Over here I'd get AD equals BC. Over here I'm going to get A plus B times D equals C plus D times B. Now if I simplify here, I'm going to get AD plus BD equals BC plus BD. And if you notice, I've got BD in both spots. So if I subtract that away, it goes away and I still get AD equals BC. So that's why you're allowed to do that. The big concept here is the geometric mean. The geometric mean of two numbers is a number that can be both means. So it takes up the spot of both of the means in the proportion. Where the numbers, the two numbers mentioned up here, are the extremes in the proportion. So the geometric mean of A and B would be X if and only if X is in both spots, in both mean spots. So if they ask, what is the geometric mean of 8 and 9? Well, that means I'm going to put 8 and 9 in the extreme positions. And I'm going to be looking for a number that I can put here that makes this true. So 8 over something has to equal something over 9. I'm looking for that number that makes this ratio the same as this ratio. Because that's what a proportion does. It takes one ratio and says it's the exact same as a different ratio. In order to solve this, I'm going to use the cross product property again. I'm going to take 8 times 9 and set it equal to x times x, which is x squared. It is not 2x. To solve for what x is, I'm going to square root both sides, which means I have to do my simplest radical form. So I already know what 72 is. I just found it by taking 8 times 9. 8 is 4 and 2. 9 is 3 and 3. 4 is 2 and 2. So I've got 2 times 2 times 2 times 3 times 3. I have a pair of 2's and a pair of 3's. The 2 stays in, so I have 6 square root of 2. That is the geometric mean of 8 and 9. Okay, and I can check this by putting it in and checking. So 8 over 6 square root of 2 should equal 6 square root of 2 over 9. Does it? Okay, you could type this on your calculator and type this on your calculator and you should get the same number. Or we can just cross multiply again and check it. 72, 8 times 9. 6 times square root of 2 times 6 times square root of 2. 6 times 6 is 36. Square root of 2 times square root of 2 is 2. 36 times 2 is 72. These are equal. Here's some examples. Alright, so I'm given a proportion here. They're telling me this is true. They want me to find the length of GK. Well, HJ, I see that it's 6, so I'm going to put 6 in place of HJ. JL is 12. GK is X, that's what I don't know. KL is 10. And now I can cross multiply to find my answer. 60 equals 12x. Divide by 12. X is 5. Find the geometric mean of 105 and 210. 105 over something is the same as x, is the same over that same something over 210. Okay? So, I could go through the process of multiplying 105 and 210 together and get some big number. But since I know I'm going to be square rooting them, okay, because it's going to equal x squared, I'm going to have to square root, I'm just going to leave them separate. 105 times 210. That's going to make it easier for me to break down. 105, okay, I know it's divisible by 5 because it ends in a 5. Okay, 5 times 20 is 100, so 5 times 21 is 105. 21 times 10 is 210. Okay, I'm choosing to use that one because I already saw this 21. I don't need to break these any further because I can see right now I've got a pair of 21s. Using that same notion, I'm going to break this to 5 and 2, and I've got a pair of 5s. So a 5 and a 21 come out, the 2 stays in. 5 times 21 I already knew was 105. So this is the geometric mean. If you notice, if I had broken the 210 down first, I could have said maybe that's 105 times 2. And then I could have just circled the 105s together and brought them out right away. Alright, here's a practical application for this. You have a 10 by 8 inch photo that must be reduced to a length of 5.5 inches. Okay, length, width. What will the resulting width be? Well, in order to keep the photo from stretching out, right? Because I don't want our faces to get all stretched out. So let me show you what I mean. All right, so I've got an image of Georges St. Pierre, greatest fighter of all time, and if I've got this picture of him, and it's 8 by 10. Okay, 10 by 8. Okay, I want to keep that same dimension because if I don't keep the same dimension, Georges St. Pierre is going to look weird, okay? I want to keep the same proportion. So I don't want him to get stretched too thin or get all squished up. Okay? So what I need to do is set up a proportion that's going to maintain this ratio, because this is the ratio of the original photo. I want to make sure I have that same ratio in my new photo. So I need 10 over 8. So length, width, to equal the new length, which is 5.5, over the new width, which I don't know. Now, that's not the only way to set your proportion. There are actually more right ways to set the proportion than there are wrong ways. Because as long you just need the things to be related, okay? 10 and 8 are related because they are in the original together. 5.5 and x are related because they're in the new together. 10 and 5.5 are related because they're both the length. 8 and x are both related because they're the width. So as long as I keep everything related to what's either above or below it and across from it, I'll have a correct proportion. So an example of another way I could set this up. My original length over my new length has to equal original width over, this is new, so I need new down here. Okay, and of course I could reciprocate all these too, so I could have, so I could have 8/10 has to equal x over 5.5. That's our reciprocal property. I could reciprocate this. I could switch the means, which is basically what I did here. I just switched 8 and 5.5. So we can switch means. I could reciprocate this one. 5.5 over 10 has to equal x over 8. So what I would suggest is picking the proportion that gives you x on top, because those are easier to solve usually. I mean, you can always cross multiply, but this one's going to be so much easier because in order to get rid of the 8 on the bottom, I just need to multiply both sides by 8. Okay, because that'll cancel the 8 here, and I'll have x. And here, I can cross reduce here. So this becomes a 5, and this is a 4. Okay, and if I take this and turn it to 2 and 2, I can use one of those 2's with the 5.5 to make it 11 times the other 2. Is going to be 22. So I'm going to have 22 fifths. Which, since I have this in decimals and we're measuring, I might want that as a mixed number. So this is going to be 4 and 2 fifths, which is 4.4 inches. And that's going to be the new width of my picture.